Hello, AFDA students. This video is to help you with your project planning guide part 2, just in case you are working ahead. So the first thing you need to do is find your project planning guide part 2. In Schoology, you're going to go to the Unit 1 function machine. It's going to come. All right, and then part 2 should be in Unit 1, Day 6. So you'll open your assignment, and then it says from your planning guide part 1, copy your equation and your table of values. So your equation and your table of values in project planning part 1, that was in day 4. So you need to open this assignment up. And when you open your assignment, you should have your saved work. I don't have saved work in here because this is just the assignment, but you should have your saved work. And so down here, your equation is right here. And this is a great time to convert your equation to function notation if you, if you didn't use function notation yet. Remember that you're just going to change your y equals to f of x equals. And then down here you have your table of values and yours will be filled in. So you can just copy it, highlight it, Control C, and then you can paste it into your assignment here. Okay, so you can see that I did copy over my equation here, and I'm going to bold it just so I don't lose it. And then here's my table of values. Now it says on Desmos, you're going to graph the table with a scatter plot and graph the equation and label the axes. So you want to go to desmos.com. And we're going to put the equation on the line. And you can do it in function notation or just regular y equals. F of x equals 3x plus 1. And then over here, you're going to use add item, and you need to add the table. All right, and you can just type in the table that you used. All right. So there are two things I still need to do. One is I cannot see all of my points, so I'm going to fix my axes. And the other is I want to label my axes. So you can zoom in and out with these buttons, but if I zoom out like this, you see how my points are right here, and there's all this empty space here. So zooming in and out is not a perfect solution. I'm going to go to the wrench here. For my x's, I need numbers 0 to 4, and I'm going to start a little bit before 0 and I'm going to end a little bit after 4. So I'm going to start it at -1, and I'll go to 5. And now you can see that your x-axis goes from 0 to 5. For my y-axis, I need to show the numbers from 1 to 14, and I'm going to start a little bit below 1, and I'm going to end right after 14. I could start my y at 0, but I like to be able to see the origin well right here, so I'm going to start my y at -1 also. And then I'll end after 14, so I'll end at 15. All right, so let me just show you real quick. You can see all 5 points now. This one's off the line, which lets me know that I made a mistake. And I can see it right here. This number is supposed to be 13. There it is. Okay. Now I need to label the axes. So my machine was increasing the number of lanes for traffic. So if I go back to the wrench here, my x-axis, the label was the old number of lanes. And then my machine created more lanes. So that's the y-axis is the new number of lanes. So if a road used to have 4 lanes for traffic, now it has 13 lanes for traffic. All right, and so now you can see my axes are labeled, I can see the points, and I can see the line. I'm ready to copy this into my document. So the easiest way I have found to copy it is over here with this share graph. But now that I'm thinking about it, you want to save this in case maybe there's some small mistake on it and you want to fix it later. So the first thing you need to do is log in over here. If it says your name, you're already logged in. If it doesn't say your name, you're going to click login and then log in with Google and use your FCPS Google account. And over here where it says save, click on that. You're going to give it a title like Project One Graph and save it. And then next time you open Desmos and after you log in, where these 3 lines are here, you will see all your saved graphs and you'll be able to get back to it. All right, so now let's copy your graph. So we're going to go to Share Graph. And this time we don't want the link, we actually want the picture of the graph. So I'm going to go to Export Image. Do not go to Download. You're going to go over to the graph. You're going to right click and you're going to copy the image. And then you want to go back to your document and where it says Desmos right here. I'm going to use Control V to paste it in. And you can resize it to whatever size seems reasonable for you. All right, so now it's asking questions about the intercepts. It says, what is the x-intercept? What does this point represent? So you'll remember x-intercept is where your line crosses the x-axis. And looking at your graph, you can kind of tell where it is. But if you return to Desmos, you can see exactly where this point is. So here's my x-axis, and if I click on the point, it should say my y is 0. So here's the right point, negative 0.333, comma 0. All right, and what does this point represent? Well, remember that the x is the old number of lanes and the y is the new number of lanes. So if my old, oops, I put my place, number of lanes is negative 0.333, the new number of lanes is 0. Now, if that doesn't make any sense to you, well, then you are really thinking about this right, because you cannot have negative lanes of traffic. You can't have 0.333 lanes of traffic. So even though this point doesn't make sense, that's what it represents. And you might want to write a sentence about whether it makes sense. All right, next, the y-intercept. Again, you can probably see about where the y-intercept is right here. But if you go on to Desmos, you can click the point where you intersect the y-axis at 0, 1. And then we will put that into your project. What is the y-intercept? The y-intercept was 0, 1. And again, the x is the old number of lanes and the y is the new number of lanes. So if I start with 0 lanes, I get 1 lane for traffic. That one does make sense. Okay, what is the practical domain of your function? Remember, practical domain only includes input values that make sense for this situation. So even though I graphed a line that continues forever, and the line contains all of these fractional points in between, for lanes of traffic, I can't really have a fraction of a lane of traffic. So for my domain, I'm going to list integers, and the integers also can't be negative. So my practical domain is non-negative integers. So I could have 0, 1, 2. So I'm going to use the fancy brackets to start listing them. 0, 1, 2, 3. It's hard to say where my domain would actually stop, because eventually you can't build a road with that many lanes of traffic. But because I'm uncertain of that, I'm going to just use the ... to say that that could continue in that pattern. Now the range is what you're going to get out of the function. So remember, up here, I have some outputs. These are some possible outputs. And again, those could continue as long as I can continue to build a road that has that number of lanes. So my range is going to be the outputs of the function, and those were 1, 4, 7, 10, 13, and possibly it could keep going from there. Is your function increasing or decreasing? So remember that you read the function from left to right. So going from left to right, I am increasing. And that means as the old number of lanes increases, the new number of lanes is also increasing. Okay, so now we're getting to definition of function. It says, how is your machine a genuine function machine? Explain how a competitor's product is not a function machine. Look at the definition of function and the examples and non-examples for ideas. Write a paragraph of at least 3 sentences. So remember that in order for a relation to be a function, every input has just one output. You always know what you're going to get out of the machine. Remember we talked about a Coke machine that was not a function machine because when you press the Coke button, sometimes you got a Coke or sometimes you got a Sprite or sometimes you got a Fanta and you couldn't know what to expect. So your machine is a genuine function machine because it's quite reliable. So let's look back at the sample project to see how I explained genuine function machine before. So right here it says, let me see if I can make this view bigger. Don't trust our competitor maybe lanes. Their product sometimes produces more lanes and sometimes produces less lanes. Maybe lanes is not a genuine function machine because each input is not paired with only one output. So you can see how I explained my competitor. That was not a function machine. And I'm just going to copy this over so that I don't have to waste your time with the typing right now. All right. So then it says using full sentences, describe in words what happens if your machine is used backwards in inverse mode. So think back to the expert activity when you taught each other and you taught about inverses. Inverses undo the function. So looking back here, my function is multiply by 3 and add 1. And remember, I need to undo those in a backwards order. So first I need to undo adding 1, and then I have to undo multiply by 3. So the function would subtract 1, and then it would get rid of the times 3, so it would divide by 3. So it would look like this, f of x equals, and then I need to do x minus 1. And then to show that that happens first, I'll put parentheses around it. And then divide it by 3. Okay, and that actually is down here where it says write the equation. All right, and then looking back at the project, you can see how I incorporated this into the project. Caution, do not use traffic magic in inverse mode. Inverse mode would subtract 1 lane and divide the remaining lanes by 3. This would often result in fractions of lanes and would always reduce the number of lanes, making traffic even worse. All right, so when you are done with this assignment, you can submit it in Schoology, and then you'll be ready to start working on your flyer.